Thank you. Good afternoon to one and all. So today's session will be a continuation based on the previous session. So in the previous session, we saw the very basic fundamentals regarding Python. And now we are going to see a topic called operators, the control flow statements, what is supported by the Python programming language. So operators, we all know the normal mathematical operators, the every operator will be supported in terms of programming language also, and they have been categorized in such a way your Python is going to support some 7 categories of operators. So we will be seeing the operators. So new operators alone will be discussed in detail. So this session will be based on operators control flow statements, that is conditional and looping statements. So these are the 7 categories of operators supported under Python. Arithmetic operators are like normal mathematical operators, what is supported by Python. Comparison or otherwise called as relational operators are these normal operators what we know, and the output of comparison or relational operator will be a boolean value, either a true or a false, depending on the condition what we are going to check. Assignment operators like normal assignment and the plus equal to, minus equal to, division equal to are called shorthand assignment operators. So they can be used to the equivalent expression. So we'll be seeing with the example. Then logical operators, the other name for logical operators is boolean operators. When you want to test multiple conditions, boolean operators can be used. When we want to test multiple conditions at the same time, we can apply this logical operators and or not. In bitwise operators, it is going to operate upon the bit level data, that is every data will be converted into zeros and ones, and to the zeros and ones the bitwise operator will be applied. Next one, membership operators, and these are applied with the sequence data type, that is list, tuple, string. A membership operator will test the presence or absence of a particular value in that particular data type. Identity operators. So the operator names here, it is in is an operator, not in is an operator. Name of the operator itself, in and not in. Identity operators, it is for checking the equality or similarity of the values, similarity of two different operands. So is and not in, not is not is the name of the operator. So there should be spacing wherever needed. There should be all are keywords, so we cannot change the spelling here. So these are the 7 categories of operators supported under Python. So we are very much familiar with the arithmetic operators, comparison or relational operators, and assignment operators. Just for short and assignment operators alone, I will show an example. For the remaining 1 or 2 examples, we will be seeing in the idle window. So I'm taking 2 different operands. So all these operators will operate upon 2 different operands. All are called binary operators. So we want 2 operands for it to be applied, for every operator to be applied, except not logical not operator. All are binary operators. So they will require 2 operands for its operation. So I'm just taking some 2 different values. So arithmetic operators, I don't want to show it very elaborately. I would like to run with very few operators. Just to demonstrate some few operators, I have taken a simple coding with the two operands. Here my operands are going to be A and B with some values. So I have applied it to as a script file. So I'm going to run the module. So if it is an interactive mode, immediately we would have seen the output. So here I would apply on a script mode. So nothing is visible as I did not give print statement here. So it was empty actually. The print will print the value stored in that particular variable. These are the corresponding outputs for our operation. So I have taken a value A equal to 5, B equal to 10. The next operation, I'm just doing the normal addition operation. In C, I'm storing the result in C. D, I'm just doing comparison operation, A less than B. So if that condition, particular condition A less than B is true, depending on the value of A and B, it is going to give true, otherwise false. So we can see the outputs, corresponding outputs in the parallel screens. I hope the screen is visible. Then E, I'm just checking the not equality of A and B. Obviously that is true. So it is giving the output as true, a Boolean value. The next one, F, I'm applying a bitwise AND operation. So bitwise AND bitwise or what actually does is the value A equal to 5 will be converted to a binary value. Similarly, the value B equal to 10 will be converted to a binary value. Then as per AND truth table or truth table, what we know already, it will be applied to every bit, that is every 0 and 1 is it is considered as a bit. So to every bit of A and B, the particular operand, that is AND means AND as per AND logic, OR means as per OR logic, it will be applied. So the corresponding output will be displayed again for us when we apply a bitwise operator in terms of decimal value, in terms of decimal value. So when I apply bitwise AND operation to A and B, the corresponding output what I get is 0. Similarly, when I apply bitwise OR operation, the corresponding output what I get is 15. At the last, for your reference, I have given a statement. These are the operators. So when I give the print statements in the previous lines, it is going to print the value. Whereas when I give something within double quotes, whatever I give within double quotes as such, that is going to be printed on the screen. So I want to show the difference between the previous print statement and the current print statement. That is why I have given like this. So this is about very basic, very few operators. And I would like to share a screen showing bitwise operations. Reminding we know, so bitwise I will show. So these are the bitwise operators, bitwise and bitwise or bitwise XOR, exclusive or bitwise not, left shift and right shift operation. So what it will be doing, it will taking the both operands, converted to a binary value, and to every bit of that binary value, the particular operator will be applied. So this is an example to show bitwise operator. So I have bitwise and, so taking x and y value and applying means the final answer alone will be displayed by the bitwise AND operation. So x value and y value both will be converted to a binary, and to every 0 and 1 of both x and y, a particular AND logic will be applied. So AND, as per AND logic, when both inputs are 0, output will be 0. When both inputs are 1, output will be 1. When it comes to OR logic, when any one input is 1, the output will be 1, otherwise it is 0. Bitwise not, it is a unary operator, so it is applied to a single operand. Whatever operand we apply, the reverse of that, the complement of that will be given by bitwise not operator. So it is denoted with the symbol tilde symbol. It is bitwise not is denoted with the tilde symbol. For example, if I give x tilde of bitwise not of x, where x is equal to 10, so the corresponding decimal binary value of x equal to 10 will be converted to the complement. If the input contains 0, the output will be containing 1. If the input contains 1, then the output will be containing 0. So to be very simple, when I apply bitwise not operation to any value, for example x equal to 10, the output of that will be minus of 10 plus 1. Minus of 10 plus 1. So the output will be like minus 11. Suppose if I apply x equal to 20, the output will be like minus of 20 plus 1. So the output of bitwise not operation on 21 is, so on 20 is minus of 21. That will be the output. Bitwise right shift and bitwise left shift. So it is denoted with 2 greater than symbol and 2 less than symbol. So right shift means 2 greater than symbol, left shift means 2 less than symbol, and here also they are unary operators, so they will be applied with a applied on a single operand only. So what is that 2 means? It indicates how many positions we need to perform the shifting operation in the left or the right. The constant value 2 indicates 2 or 3 as per what we give. It is a constant value. It indicates the number of positions to be shifted of the corresponding value to which it is applied. So when I apply a right shift operation to x equal to 10, after the operation I am getting the output as 2. Similarly, when I apply left shift operation to x equal to 10, the output of that operation is going to be 40. So bitwise shift is shown like this with the help of this GIF image. So I hope the screen is visible. So here it shows your left shift operation with respect to the constant value 1, with respect to the constant value 2. It is applied with the initial value 14, and the 14 binary representation is shown for your reference. So after performing left shift by 1 position, your output is changed to 28. 14 has been changed to 28 after the left shift operation. Similarly, when I apply left shift to 14 by 2 bit positions, the output is will be 56. So the same thing when I do for right shift operation. So when I apply the same operation with respect to right shift by 1 bit position as well as by 2 bit position, the output of 14 is equal to 7, the output of 14 is equal to 3. So after seeing this, I would like to tell one small information regarding this bitwise operator. So when you apply bitwise operator to decimal values, internally the conversion of binary value will be taken place and the output will be coming displayed back in decimal numbers. So the logic to get your left shift value or right shift value of any number is, for left shift operation it is a multiplication. It is a multiplication factor, whereas when it comes to right shift it is a division by. So when I apply a left shift operation to a number n, the output will be n star that position, n star that so many positions. For example, if I perform left shift of 14, it means the output will be, when I perform a left shift operation of 14 by 1 bit position, the output will be like 14 star n star 2 power 1, n star 2 power 1. So 14 into 2, 28. Similarly, when I perform left shift operation to 14 with respect to 2 bit positions, the output will be n star 2 power 2. So n star 2 power 2. 14 into 2 power 2. So 2 power 2 is 4. So when I multiply 14 into 4, the output will be 56. When it comes to right shift, it is a factor of division. So when I want to find out any right shift value of a number, means I have to do this logic, that is the number divided by 2 power n. Number divided by 2 power n. For example, as shown in the screen, when I apply right shift to 14 by 1 bit position, the output will be 14 divided by 2 power 1. So 14 divided by 2 power 1 is nothing but 7. Similarly, when I perform right shift operation by 2 bit positions to the number 14, that is 14 by 2 power 2. 14 by 2 power 2, so 14 by 4, which is 3. And the output will be, definitely we have to consider the integers only. We have to take out the integers only, not as a decimal. When we apply this logic of finding out bitwise left shift and bitwise right shift value. So actually internal operation is demonstrated here. The shortcut of knowing the left shift value and right shift value is, for left shift it is a multiplication by 2 power the number of positions, 2 power n, where n indicates the number of positions. Similarly, right shift it is 2 by 2 power, number divided by 2 power n, number where n indicates the number of bit positions to be shifted. So this is about shifting operation. So when I have just taken a sample program to show for with x equal to 10 and y equal to 12 and applying every operators, so that the last the output what we get is shown for your reference. So bitwise operation and operation is giving the output as 8 for the value 10 and 12. OR operation is giving us 14, XOR operation is giving us 6, NOT operation is giving minus 11 when it is applied to x equal to 10. So 10 plus 1 before minus should be coming. So minus of 10 plus 1. Left shift position. So as per this logic, we are applying with x. So x value is 10. So x star 2 power 2. So 2 power 2 is 4. 10 star 4 is 40. That is the answer we get. Right shift operation, similarly, we need to do division. So 10 divided by 2 power 2. 2 power 2 is 4. 10 by 4, we get the answer as 2. 10 by 4, we get the answer as 2. We need to consider only the integers here. Next one, identity operators. So we have two operators supported here. The name of the operator is and is not. They are used to check the identity or similarity between operand 1 and operand 2 to which they are applied. The output of this will be a Boolean value. So is will give you true if both the operands are identical. Is not will give true if both the objects are not identical. Membership operators, we have in and not in. So they are used to test the presence or absence of a particular element in a sequence data type, that is string, list, tuple, set, and dictionary. So here also the output will be a Boolean value. So in will give true if the particular value is present in the sequence data type. Not in will give true if the value is not present in the sequence data type. So this is the logic or truth table shown for and or not. So and is going to give true when both are true. Otherwise, it will be giving false for remaining inputs. Or operation will give true when any one input is true. Otherwise, it will give false. Not means when you apply with true, it will give false. When you will apply with false, it will give true. It is a unary operator. So I'll just show the use of membership operators. So I'm just taking a string hello. I'm going to check whether h in hello, or I'll just show h in a. So it will give me error. The reason is h is a string or a single character. Whenever we use a character or string, we need to give within single quotes or double quotes. So if I do the same thing like this, h in a, as the character h is present in the particular string, the membership operator in is checking whether it is present or not. So as it is present, it is giving true. The same thing if I do like this, it is giving false. The reason is it is comparing with case. It is comparing with case. So when I give the same thing with small case h, it will tell true. So this is in operator. When I give the same thing, it is giving false as h is actually present, but I'm asking the absence whether it is I'm telling whether it is absent in a. H not in a means I'm telling it is not present, but actually it is present, so it is giving me false. So this is the use of in and not in operator. So these are applied with the sequence data types, string, list, tuple, or dictionary kind of thing. So only I have just taken a string for explanation purpose. So the remaining data types are along with list, tuple, dictionary will be covered in tomorrow's session. So that is the reason I did not go with other different data types here. So just for reference, I have taken string alone and showing some yesterday's a basic operation and today's examples also. Next one is and is not. So I have to take two different operands for this. So I'll take one string hello, next string world. So I'm going to check the identity of A and B. So A is B. Actually, it should give false. It will check whether A and B refer to the same object. So it is giving false. Suppose I'm giving A equal to hello. Similarly, B equal to hello. Can you say the single quotes or double quotes? So I'm using single quotes in one case. So A is B. Now it is giving true as A and B contains the same value. Suppose I'm giving A is not B, and it is giving false as both are identical. Suppose I'm giving the same thing B equal to capital case A is B. If I do like this, it will give me false as it will refer to the case also. So even though both contains the same string hello, it is comparing the case of that particular string. So it is giving false. So A is not B. Now it will give you true. Give true. This is the use of membership operators and identity operators. So arithmetic operators, I did not go in detail. We all know the arithmetic operators use. Then relational, that is comparison operators, we know. So very few assignment operator I would like to show. A equal to 5, B equal to 10, A plus equal to So this is the use of shorthand assignment operator. So assignment operator we know just for assigning a value in the right hand side to the variable in the left hand side. Shorthand assignment operator. So this expression is equivalent to A equal to A plus B. Instead of writing the expression in that way, we can use the shorthand notation A equal to plus B. A equal to plus B. So the meaning is it is equivalent to A equal to A plus B. This is the use of shorthand assignment operator. So relational or comparison operators we know less than greater than those conditional testing. So the output will be true or false. Arithmetic operators, it is for arithmetical calculations. Then identity operators I demonstrated now. Membership operators also I demonstrated now. Next one, shorthand assignment operator. Only one example I have shown what is the use of shorthand assignment operator. Next, bitwise operators I have shown. So for example, I just give A equal to 10. Bin of A will give me, bin is a inbuilt function. It will give the binary value of the corresponding value what I give. So if I give like that for your reference, I'm getting the binary value of 10. Next, I'll take the binary value, for example, 14. So bin of 14, sorry, B. So these are the corresponding binary values of A equal to 10 and B equal to 14. When you apply A ampersand B, the corresponding value is 10. Or ampersand B. So for your reference, I'm just showing the corresponding decimal values as well as binary values, and after applying the operation, what is the value we are getting. Similarly, I'll apply A or operator B. This is the corresponding binary value. Now for our reference, I'm just giving what is the decimal value here, A or B, 14. So this is the corresponding binary value shown at the above, and the corresponding decimal value is shown below. Similarly, I'll apply not operation on A. So this is minus 11. So for reference, I'm just giving what is the corresponding binary value of this operation minus of the value of 11. 11 is the corresponding decimal value. So next I'll show left shift and right shift operation. So bitwise and bitwise or bitwise exclusive or bitwise exclusive or I will show. So I'll show the corresponding binary value also. This is the binary value of 4. The equivalent decimal value is also shown for the reference. That is bitwise exclusive OR operation. Next one, the left shift and right shift. So A, left shift 2. So A is 10 actually. So the output should be coming like 40. 10 into 2 power 2, 40 should be coming. So actually 40 is coming. For reference, I am also demonstrating what will be the shifted value of 2 after this operation. This is the corresponding binary value after doing shift operation by 2-bit positions on the binary value of A, which is 10. Okay. Next one, 2. We are getting 2. That is 10 divided by 2 power 2. 10 by 4, which is nothing but the integer value of this division operation is 2. So it is giving 2 there. So for reference, I'm just demonstrating the binary value also. So we are getting the corresponding binary value of this operation. So these are the various operators that is supported under Python. Next topic I shall be moving with control flow statement. So whenever we want to test any conditions, we can apply conditional statements. Whenever we need to repeat certain operations, we can apply that under looping statements. So control flow statements are nothing but they will decide what is the flow should be followed in our program. Either a line by line execution should take place, or some lines can be skipped. The control has to change based on some conditions, means they are the statements supporting this will be called as conditional statements. When we want to repeat certain actions, certain statements to be again and again executed, means we can apply the looping statements. So for reference, what is selection, sequence and iteration control? Selection control means one by one the execution will take place. Sequential control means one by one, line by line execution without any change in the control flow. When it comes to selection control, it is based on a conditional testing, either true block should execute or the false block. Here we need to do decisions. Iteration control, here if the condition is true, particular set of statements shown in the loop will be again and again executed. So if that condition is false, then that particular loop will stop executing and it will go to the next statement available in the program. So the conditional statement supported is if statement, if else statement, if else statement, nested if else statement. The syntax, what is the syntax we need to use for if statement is it should have a if keyword. Then within parenthesis, we need to mention the condition what we need to test. After that, we should have a colon. It should have a colon. Colon is very much compulsory. Wherever we have a colon in a particular Python statement, below that statement or next immediate statement below that colon will be indented definitely. So here you have shown a indentation in the syntax itself. So whenever you have a colon, the statement, immediate statement below that colon should be indented. The indentation is needed to tell it belongs to that particular block. In other programming languages, curly braces are used to indicate block of statements. In Python, no curly braces is available. Only indentation will tell which is the beginning of the block, which is the end of the block. The line which is indented will tell the beginning. The line where indentation is stopped will tell the end of that particular block. So this is the flow control for if statement. So as per the control, it will test the condition. If the condition is true, the statements below the if block will execute. Otherwise, false means whatever statements we write outside if. This inside if and outside if is nothing but depending on the indentation. If I have indented four statements below if, that means all the four statements belong to if block. If I indented only one statement, that only one statement belong to if block, remaining statements are outside the if block. Alternative if else. So here only true part is there. True means if block, false means we did not give any action to take. In the case of if else, true means if block should execute, false means else block should execute. So block in Python is given by indentation. That is most important. Indentation is very much important. So when the condition is true, statements in the true block will execute. That is if block. When the condition is false, statements inside else block will execute. Chained conditional, we can test multiple. Till now, we saw only one condition here. In the case of if as well as if else, only one condition can be tested at a time. Suppose I want to test multiple condition, that provision is given by this if elif else statement. So we can have multiple elif blocks where we can test multiple conditions. So if is going to have one condition, elif is going to have another condition. If we want one more condition, we can use another elif. Elif is the short form for else if. It is a keyword. If is a keyword, elif is a keyword, else is a keyword. So this is the syntax. Condition 1, that is true, if block will execute. Otherwise, you can test for the next condition. If that is true, the corresponding elif block statement will execute. Like this, we can have multiple conditions tested. So if no condition is and coming as true, then the false part is defaultly given in the else block. False part is always written in the else block. When you want to test multiple conditions, those can be given under elif blocks. This is the flow control for elif, if elif else. Then nested conditionals. We can have one if block, one else block within another if and else. That is called nesting here in terms of programming. One block within another block, one else block within another else if block, one if block within another if block. Like this also we can do conditional testing as per our need. So conditional statements are these: if else, if else, nested if else. Iteration, that is looping or repetition, can be when you want to repeat certain statements. So we need to tell when the control has to repeat the statement. So when the particular condition is true, the particular statements has to repeat again and again. When the particular condition is false, the statements should not repeat. The control has to come outside of that particular block. So in a Python, that is provided with two statements, while and for. So while loop, the syntax is shown here. So it should have an initial condition. So this initial condition will tell when the loop has to begin. When the loop has to begin is decided by the initial value. Then while is a keyword. Within parentheses, we need to give the condition. Colon is compulsory as per the syntax. So when the particular while condition is true, the statements be inside the while block, and all the statements what I want to repeat after the while condition should be indented within while. So when the particular condition is true, all the statements inside while should be executed repeatedly. If the particular condition in the while is false, then all the statements inside the while loop should not repeat or should not execute. So this is the flow control for while loop. You are going to test a condition. If that is true, body of the while is executed. Again, the control will go and test the particular condition is true. If it is still true, again this will repeat. If it is false here, then whatever statements we have outside while will be executed. And this initial value should be incremented inside body of the while loop. So if the initial value is not incremented, the while loop will keep on, will be true only. So the incrementation should be given inside the while block or while body. We can use while with else also. So whatever, until the condition of while is true, the body of while will execute. Once it is false, the else block will execute. Nested while, one while within another while is also possible. Next, for loop. So this for loop is used to apply with sequence data types. Uh, for moving or traversing in the sequence data types, for loop is used. The syntax is it should have a for keyword, then it should have any iterating variable name. This variable name is defined by the user only. In is a keyword, and what sequence you are going to apply, either a string or a list or a tuple. That should be given here. The name of the string or name of the list or name of the tuple should be given. So iterating means moving from the beginning to the end, or otherwise this iterating is called as traversal, moving from one element to the next element without missing any element. At least one time the particular element will be accessed. So for example, for loop is applied with a string. For is a keyword, I is the variable, iterating variable, in is a keyword. I'm applying on the string Python. So when I just give, so this for loop, we need not do any incrementation or decrementation. Automatically, the initial value will be considered as 0 in for loop. The final value will be till the end of the particular sequence data type. So we need not do incrementation as shown separately in the while block. Automatically incrementation will take place. So for I in Python, when I equal to 0, P will be accessed. When I equal to 1, Y. When I equal to 2. Like that, every character can be accessed from the string Python. So here no initial value is needed. No incrementation is needed. Auto incrementation can take place with for loop, whereas when it comes to while loop, we need to increment by using coding. We need to do incrementation operation. So every time when a particular character is accessed, that is printed by print of I. So I will be referring to the particular character in the sequence data type. Automatically it can increment. I did not give any incrementation or initial value for this for loop. Then this for can be used with an inbuilt function called range function. So this range function can be used with for loop, can be used with for loop. The syntax is, it will, the name of the function is range. It will take start, stop, comma, step size. Start will tell from where the range of numbers should be taken, what is the starting value for it. Stop will tell what is the ending value for the range of numbers to be generated. So the range function uses automatically the numbers will be generated based on the starting index and ending index supplied in the range function. And step index, if we don't provide, it is 1. The step index is provided as per the gap of step value. The next number will be taken for operation automatically. This is the syntax for range function. For I in range, start, stop, and step. Colon. So this step is optional. If it is not provided, 1 will be considered for step. So this is the flow control for loop. When the condition is true, body of the for is executed. False means outside the for body. And the false part can be given in else block also. We can have nested for also. That is one for within another for. So like this. So here the control is like for I in range of 1, 4 means the range of numbers from 1 to 3 will be taken excluding the ending index. as I said, for slicing operation, here also the ending index number is excluded. So for the range of values for I will be 1, 2, 3. Similarly, for j, it will be 4, 5, 6. The starting value is 4, 5, 6. For j, for I, it is 1, 2, 3. And the control is like, it is a nested for loop here, one for within another for. That is, one for will be given inside the body of another for loop. So for I in range of 1, comma 4, for j in range of 4 comma 7, until the outer, that is I loop, is true, the control will come inside the body of the for loop. When the outside I loop is false, then the control will not execute the two statements inside the for body. Suppose it is coming when I equal to 1, the condition will be true. What is the condition here is, the number 1 is lying within the range 1 comma 4. If the number, if I is equal to 5, it is outside the range of I comma 4. So it will, the outer for loop itself will be becoming false. So when I is equal to 1, control moves inside the for body. There is again a for loop. Now j value will be taken as 4. So 4 is lying within the range 4 comma 7. Here also the condition is true. It will come inside the for body for this j loop. So this print is indented j loop, within the j loop. So I star j means the I value is now 1, j value is now 4. So 1 into 4, 4 will be printed. Now the control will again go to the j loop. It will not go to the I loop, it will go to the j loop only. The reason is, when this, until the for body is true, the control will go to that particular for body only. It will not move outside that. So now j value will be automatically incremented to the next value in the range, that is 5. So now j is 5, I is 1 only, because the control is not moved to the for body yet. It is inside the body only. So when I is 1 now, j is 5 now. So 1 into 5, 5 is printed. Similarly, again, j is automatically incremented to the next value, which is 6. But I is still 1 only. So 1 into 6, 6 will be printed. Now I is further incremented to 7. So 7 is outside 4 comma 7. So as I said, range function excludes the ending index, so it will not take 7 for operation. So 4, 5, 6. So it will be false. So immediately the control goes to the outer for loop. Now I value is incremented to the next value 2. So 2 is within the range 1 comma 4. Again it comes inside the for body. Now j value is again reinitialized or reset to 4. Reset to 4. Once it is false, again whenever it is accessed, it will be reset to the initial values only. So now j will be equal to 4. I will be equal to 2. 2 into 4, 8. So like this, just this example is taken to show the flow control for nested for loop. So range function example is shown with one parameter. So if I give a single parameter, that one parameter will be taken as stopping value only. Stopping value. So what will be the starting value here is 0 comma that stopping value. So when I give for I in range of 5, it will be taken as 0 comma 5. So it will be printing up to 0 to 4. 0 to 4. When I give two parameters for range function, first one will be considered as starting value, second one will be considered as stopping value. So 5 comma 10 means 5 to 9 will be considered for operation. So it will be printing 5, 6, 7, 8, 9. Okay. Next, suppose if I give three parameters, start, stop, and step. So the values taken here is 5 to 9 with a gap of 2 between every value. So 5, next value will be 7, the next value will be 9. There will be a gap of 2 between the values taken for operation. So if I give 3 here, the meaning is 5, 8, 11. Actually 11 is not taken, as the range, ending range is 10 only. This is about a for while. Next we see loop control. So the loop is keep on executing. In between, if I want to terminate a loop, what is the possibility? So I have three different statements for terminating the loop: break, continue, and pass. Break statement will immediately terminate the loop. Immediately terminate the loop. Example, so if I give a break within this, while condition is tested, if it is true, it will come inside the while body. And if some condition is occurring, I will check whether the condition is for break. If it is there, then break statement. Once break is executed, the meaning is the control will not execute any further statements inside the while body or inside the for body. That is the meaning. Immediate termination of the particular block. No further statement will be executed. So some condition is tested. If that is true, body of the loop should execute. But before executing the body of the loop, you are checking whether there is a condition needed for break. So if it is available, true means body of the loop is terminated. Immediately it will exit from the loop. False means again further body of the loop will be executed. For example, for I in welcome. So I'm just applying this for to show break statement use in a string. So for I in welcome, the meaning is I can access welcome. But inside the for body, I have given a condition when I is equal to C. Means the left hand side is equal to right hand side. When I is accessed to C, break. Means immediately no further statement will execute inside the for body. That means print of I will not execute any further. So W is printed, E is printed, L is printed. When it comes to C, I equal to C, condition is true. True means break will execute. When break is executed, the control should come outside of the for body. So because it comes outside of the for body, print of I will not be executed any further. But when it comes to continue, it terminates only the current iteration. Current iteration means, for example, for I in welcome, if I equal to C, the same thing executed previously, that is, in the place of break I have given continue. So what it will do, when I equal to C, condition true means it will enter the if body. In the if body I have a continue statement. In the previous case I kept break. Break means control will come outside of the for loop. Continue means only that particular iteration, or iteration means when W is accessed, it is called one iteration. When E is accessed, it is a second iteration. When L is accessed, it is a third iteration, like this. When C is accessed, I equal to C, condition is true, so continue is executed. Means the lines below that continue statement will be stopped from executing. The lines below the continue statement will not be executed for only one iteration. So that means when this is executed, C alone will not be printed. So it continue terminates only the current iteration, but the control will again move to the for block. I equal to O. So that will be accessed and print of I will be executed. Similarly, similarly E. Like this, for will proceed as per its syntax until the end of the string. In between, if you have given a condition for continue, only that particular iteration terminate. Remaining can be proceeded without any break. So if you give break there, no further execution of any further statement. Immediately control comes outside. Next we have pass. So the pass is going to do nothing with your program. It will, when you give pass, it's like just a pass has happened, just a halt has happened with no operation done. Just a single pass, single halt is taken in the control. But no, it will not affect the output, it will not affect the execution of the program in any way. So here I have given pass, even though pass is executed, just like a single halt is happening, but it does not affecting the output or loop in any way. So what is the use of pass to give is, when you give a pass, the control will be halted for a moment, altered for a moment. That is the reason why we give pass there. But it will not do any operation with the program. So it is like a no operation state. It is a state called no operation. So break means terminate the loop, continue means only the current iteration is terminated. So that's all. So if I want to show with some examples, I can show you here. Try in range of 5. 0 to 4 will be printed. Sorry, I have to give colon here. That is the error. Iterating variable is given. So when I give colon, immediately the auto indent is shown here. So print of I. So the line by line it is printed in vertical direction. The reason is when I is equal to 0, the control comes inside the for body where you have print of I. Once print statement is executed once, the cursor will move to the next line or the new line. Next line or the new line. So when the further statements are executed, the values are given in the next line, not in the horizontal way of printing. It is going to the next line. The reason is if a print is encountered or executed in Python, at the end of the print statement there will be a new line character. What is the role of new line character? It will tell the next line should be printed. Next line should be printed. So whatever content you are going to print should be printed in the new line or the next line. So once one time if a print is executed, automatically the cursor will move to the next line. That is the reason here. So every value is given in the next line. So 0, 1, comma 5 if I give, so it will take up to 1 to 4. Ending index in the range is also excluded always. 1, comma 20, comma 3. So the values from 1 to 20 is taken excluding the value 20 with a gap of 3 between every value. So I'm just giving. So there is a gap of 3 between 1 and 4, 3 between 4 and 7, 3 between 7 and 10, 3 between 10 and 13. Like this it will proceed up to 19 as 20 is excluded from its operation. So if I give simply a equal to 5, b equal to 5, if a equal to b condition will be true, execute pass. So no operation is done here. If I give pass also, then just a control halt is taking place, but there is no operation difference here. That's all for today's session. Any queries, kindly ask.